All right, we're in a new unit. This unit is all on functions. We are baby stepping our way into functions. Before we jumped into this lesson, the students had a start thinking part, basically a warm-up that they had to go through, and it was trying to remind them of an 8th grade standard that was students are going to be able to identify a independent variable and a dependent variable. So in the warm-up, we had something like elevation and temperature, and you had to figure out which one was going to be the independent and which one was going to be the dependent. The best way I've found to do this is just say it out in a sentence. Does elevation depend on the temperature, or does the temperature depend on the elevation? And the temperature, we know, depends on the elevation. The higher the elevation, the lower the temperature is going to be. So what that means is temperature is going to be dependent and elevation is going to be independent. You also needed to know that your dependent is going to be your output and your independent is going to be your input. So we went through a few different ones. I'll give you one more. If it is snow shovels sold and amount of snow received, does the amount of snow shovels sold depend on the amount of snow received, or does the snow received depend on the shovels? It's not like Mother Nature is sitting there saying, I'd like to drop more snow, but we haven't sold enough shovels yet. It's the other way around. The snow shovels sold is dependent on the amount of snow that is received. So snow shovels is dependent and amount of snow received is independent. And then you can say snow shovel sold is going to be the output and the input is going to be the amount of snow received. So let's jump into the actual lesson here. On this first part, the start thinking gives the prices at a bagel store. So it says 1 bagel is $1.25, 6 bagels is $6, 9 bagels is $8, and 12 bagels is $10. So this happens a lot. A lot of times businesses are going to go over and try to convince you to buy more of something that you weren't planning on buying more of just because it is going to be cheaper per unit. So on here, it says a customer at a bagel shop is buying 13 bagels. The shopkeeper says that will be $16.25. Jada, Priya, and Han, who are at the shop, all think this is a mistake. Jada says it's supposed to be $13.25. Priya says it's supposed to be $13. Han says it's supposed to be $11.25, and the shopkeeper is saying $16.25. Who is right? Now it says explain how the shopkeeper, Jada, Priya, and Han all could be right. Now, basically, it's a way of piecing together these different costs for the prices of bagels to end up with 13 bagels. So Jada was correct because you could say that 6 bagels at $6 for those 6 bagels, that would get you $12, and then you would have to add 1 bagel, and that brings your cost to $13.25. Now, the other person, Priya, says that it's $13. Is there a possible way to get that? Yes, there is, because it says 9 bagels is $8, and then you could do 4 bagels at $1.25 a piece, and that would give you $13 altogether. Now, a different way, Han says it's supposed to be $11.25. Well, they said that 12 bagels is $10, 1 bagel is $1.25, and that does come out to be $11.25. And then lastly, the shopkeeper says it's supposed to be $16.25, and he is correct. If you buy 13 individual bagels, then at $1.25 a piece, it comes out to be $16.25. So when we think about what is dependent on what, is the number of bagels depend on the cost, or the cost is dependent on how many bagels you buy? And that is how it works. It is the cost is the dependent because it depends on how many bagels you bought. So we could also think about that as the output would be the cost and the input would be the number of bagels. So when you're looking at this, it says an input of 13 bagels can have 4 different outputs. It can have an output of $13.25, $13, and $11.25, and $16.25. Now, as you can see in the real world, this would be very problematic. If you go in to buy 13 of something and there's 4 different possible prices that could be, depending on how the person is calculating, that is a big problem. We would prefer that every input, a certain number of bagels, is going to have a single output. Technically, there is a cheapest price, so 13 bagels does have a cheapest price, and you could have a input of a certain number of bagels in the cheapest price, but as you can see here, there's 4 different outputs that single input could have. This brings us to the study of what we're talking about now, which is something called a function. A function is a relation where, and that is just inputs paired with outputs, a relation where each input has exactly one output. So in this case, one number of bagels that is an input, can only have one output, which is a cost. As we saw here, an input can have, in this case, 4 different possible, and I think there's even more that we could think of probably, but a certain input can have multiple different outputs. So that would not be a function. Anytime an input, a single input, can only have one output, we have a special word for that, and that is called a function. Remember, the input is one of the things that is the independent variable, and the output is your dependent variable. So what we do is we're looking at a few different examples here. We're trying to figure out if it would be a function or not. So you're asking yourself, is one of the independent or one of the input, is that only going to spit out one output? Is there only one possible thing that it can spit out? So here they're comparing height and age. Age is going to be the input, height is going to be the output, or you could say independent and dependent. So you're asking yourself, can only one age have only one height that comes out, or is it possible that a single age could have multiple heights if you're looking at a group of people? This is a little ambiguous, so I'm going to tell you that this is talking about an age of like a general population. This is not saying your current, if we're only looking at one person at a certain age, it's only going to have one height. But if we're talking about a group of people, a single age, I'm fairly short for my age. Most men are taller than me at the age of 41. So is it possible to have one age, an age of 41, that has multiple different outputs, which are heights? Yes, as long as you're not talking about the same person. So that one would be not a function because one age could have more than one height. The next one, would the number of dollars be a function of the number of quarters? Would a certain number of quarters spit out only a single number of dollars or multiple possible number of dollars? Well, you know, if you have 4 quarters, that can only be $1. And you can think about that with different numbers of quarters. It's impossible for a certain number of quarters to have 2 different dollar values. So that one would be a function. The next one is the value of a vehicle. Is it going to be a function of the number of years since it was made, aka how old it is? Well, I'm talking about a population. If you look at many different cars that are all 5 years old, they are going to have different values, different resale values. So since there's different outputs for the same exact input, that cannot be a function. Now, when we're looking at something like this is something that you guys should have covered when you were in 8th grade, because it's part of the 8th grade standards. X's are going to be your inputs and Y's are going to be your outputs. So a generic way of saying, is this a function, is there any X that goes to more than one Y? It's okay if there's more than one, or if there's a Y that goes to more than one X, but each X can only go to one Y. So in this case, 1 goes to 4, 2 goes to -5, 3 goes to 3, and 2 goes to 5. And this would not be a function because 2 is going to both 5 and -5. The next one, is there any X that goes to more than one Y? Nope, 2 goes to 3 and nothing else, 3 goes to 3 and nothing else, 4 goes to 3 and nothing else, and 5 goes to 3 and nothing else. So that would be a function because each input only has one output. It's okay that Y shows up multiple times, the same Y value. Now, if you're looking at a graph here, you could write down all of these locations as points and see if any X value has more than one Y value. But a different visual way of doing that, which is much easier, is just see if it passes a thing called the vertical line test. If it's possible to make a vertical line that intersects more than once, then it is not a function. So you can see here, there are 2 points that lie on that same vertical line, so no, it does not pass the vertical line test, also known as that X, I think that is an X of 2, would have 2 different Y values. One input would have more than one Y output. The next one does pass the vertical line test. It is impossible to make a vertical line that intersects more than once, so that is yes, it passes the vertical line test, aka no input would have more than one output. These actually mean the same exact thing. When you're seeing if an X has more than one Y, that would mean that it does not pass the vertical line test. Now on here, what we're doing is we're looking at the graph of a function. We are not using, we're not actually using numbers on here. We're just looking at the general shape of what the graph would look like and looking at basic characteristics and making sure that you guys understand what the different characteristics mean. So if I say a man is walking away from home, gets to the bus, stops for a few minutes, realizes he left something on the front porch, runs home, grabs the item, jogs back towards the bus stop, realizes he missed the bus, so he jogs the rest of the way to work, and then when he gets close, he slows down and starts walking. There are many different aspects here. It tells you where it starts, how fast he's going, when he's not moving, when the distance is not changing, though time is, the difference between walking and jogging. So all of those things would need to be in our graph. As you can see here, that first part of the line is not super steep because I am representing that as walking. A certain amount of distance is changing over a certain amount of time, and I'm calling that slope walking. Then a certain amount of time passes where the distance from home does not change, and that is him stopped. Then he goes over and runs home. So it's pretty steep. It has got to be steeper than when it was when he was walking and he gets all the way home. That looks like it doesn't touch all the way to the line, but it's supposed to be touching all the way to the line. Then it says he starts jogging back away from home. So it is going, you can see the line is making it so the distance from home is increasing, and it's a little bit steeper than walking because jogging is a little bit faster than walking. And then it says at some point he starts walking. So the steepness needs to mellow out. Now on here, stopped is going to be a horizontal line in here. Stopped is that horizontal line. Now in the second application here, we have a different one. Instead of distance from home in time, this is speed over time. So you have to interpret the different parts. From A to B, he is speeding up, maybe going up to like 20 miles an hour. Now here's the confusing part. A horizontal line in the graph above meant stopped because time is going by, but the distance is not changing. But this one is speed to time. So when we're looking at this, speed is staying the same. So he is not stopped. It's just a constant speed as time is going by. Then you can see he slows down quickly. He comes to a stop. Then he accelerates a bit faster than he did before. So he's getting up to speed quicker. And then he goes to a certain speed and stays at that speed. So from F to G, he is faster than he was from B to C. The main thing I want you to know here is on speed time graphs, the horizontal line does not mean he is stopped. Let's go ahead and look through these. This one right here says the relationship between the amount of time a car is parked in the hours and the cost of parking in dollars can be described as a function. Identify the independent and dependent. Does time depend on the cost, or does cost depend on how long it's parked? The cost is dependent on how long it is parked there. Describe the function in a sentence. Now your sentence is going to be the dependent is a function of the independent. That's how we do it. So that in this case, it's cost is a function of the number of hours. On here, I went over and I graphed this. I made sure to label my graph. You can see it is increasing until I got to that $12, and then it just stays at $12. The next one says the distance a person walks, d in kilometers, is a function of time and minutes since the walking began. Select all that are true. When you look at these, the only correct answers would be C and D. Now the next one is trying to figure out if something is going to be a function or not. So you're supposed to be asking yourself, does one input, one of the independent, does that spit out a single dependent / output, or does it spit out more than possible one? So it says pizzas cost $5.50 each. Some customers have a 50% off coupon. Is the cost a function of the number of pizzas? So that is saying for a single number of pizzas, is there only one possible cost? And the answer is no, because some people might have a coupon and some might not have one. It might be $5.50, or it might be, I think, what is that, $2.75, I'm pretty sure, if I'm doing the math right in my head. So since one pizza can spit out two different possible costs, one input can have two different outputs, that would not be a function. The next one, all employees earn a flat $18 an hour. Is the money made a function of the number of hours worked? Does a single number of hours give out only one possible earnings? And the answer is yes. One would be $18, two would be 36, and so on. There's not a possible way to get more than one earning amount from a certain number of hours. The next one is a little confusing. So we are writing this in one way and asking if it's a function, and then we're flipping it and seeing if it's still a function. So it says a certain phone company charges $10 per text until you've sent 100 texts totaling $10, and then every text after that is going to incur no additional charges. Is it a function? Now, I love looking at a visual approach to functions. So we look at this, the cost is going up until it gets to a certain cost, and then it just stays there. I ask myself, does this pass the vertical line test? And it does. So this is a function. Another way you could say it is a single number of text is only going to have one possible cost. Then they ask you to flip that, and they say, is the number of text going to be a function of cost? So that would be, does one cost only have one possible number of text? And that is false, because at $10, that could be 100 text or 1,000 texts. So one possible cost can have more than one number of text, so that is not a function if you write it that way. When we're looking at these ones, it says create a graph for the following. The water bottle starts as full, so it's staying full. You can see that. Dog starts slowly drinking. It's dropping down. Dog stops. It just stays like that for a while. The person refills it pretty quickly, and then the dog immediately is going to drink it very fast until it is empty. You can see all of those aspects inside of the graph. The next one is a speed time graph, and you're supposed to be determining which parts of these mean a certain thing. So it says, what is happening between B and C? I wanted to make sure you guys did not think that meant it was stopped. It would be stopped if it was distance time, but this is speed time. So it's just staying at a constant speed. Does he stop at point D? No, because you can see the speed doesn't get down to 0. It's got a little bit of speed on there. The next one, what period are they most likely on the freeway? I'm guessing, unless this is California where the freeway is stop and go, here the freeway speeds are higher than the road speeds. That would be between B and C. And then, is the graph demonstrate a function? There's two different ways you could look at this. You could say, does it pass the vertical line test? Which it does. And is there any time that has two different speeds? No. No input time has more than one output, which is speeds. So this would be a function. All right, hopefully that made sense. The main concept here is that a function is where one input can only have one possible output. One independent variable is going to have that one output, which is going to be your dependent. Thanks for watching.